This is standard 4.4. Determine if the law of cosines is an appropriate formula to solve a triangle, and use the law of cosines to find missing sides and angles in a triangle. So if we take a look at our first problem here, I know it says to use law of cosines, but let's figure out actually why we need to use law of cosines. Angle C is 37 degrees, side B is 11, side A is 8, side C is unknown. Now we can't use Pythagorean theorem, it's not a right triangle. We can't use law of sines because we don't have an angle and the side that's across from that angle. So we have, for example, angle 37, angle C, but we don't have the measure of side C. We have the measure of side B, but not angle B. We have side A, but not angle A. We don't have a match. We need a match, both an angle and its corresponding side, in order for us to be able to use the law of cosines. Now, the law of cosines says we have variations, but a side squared is equal to the sum of the other two sides squared, minus 2 times A times B, those two sides, times cosine of the original, of the angle across from the original side. So in this case, the cosine of C. So if we substitute, A squared is 8 squared, B squared is 11 squared, minus 2 times 8 times 11 times cosine of 37 degrees. We can put all of this in our calculator in one straight shot. 8 squared plus 11 squared minus 2 times 8 times 11 times cosine of 37, and we get approximately 44.44, etc. And to find C, just take the square root of that value, and we get about 6.7. So C is approximately, I don't know why my pen's doing that. C is approximately 6.7. Now once you find side C, you can use law of sines to find angle A and angle B. Refer back to standard 4.3 videos in order to do that. Let's take a look at example 2 here, using law of cosines to find an angle. So in this particular case, we have triangle ABC. Side A is 5, side B is 8, side C is 9. And it's always best to find our largest angle first. So our largest angle would be across from the biggest side, which is 9. And so we'll start with the formula C squared, because the 9 is across from angle C. So C squared equals A squared plus B squared minus 2AB times cosine of angle C. So substituting, C squared is 9 squared, A squared is 5 squared, B is 8, so 8 squared minus 2 times 5 times 8, cosine of C. C is our unknown. That's 81, this is 25, this is 64, that's 80. Okay. We can add the 25 and the 84 together, or 64 rather, I think I said 84 earlier too. 81 equals 89 minus 80 cosine C. Now what you don't want to do is subtract the 89 and the 80. That is the biggest mistake that students make. 80 is attached to cosine C. So instead we're going to subtract 89 from both sides of our equation, and we get negative 8 equals negative 80 cosine C. Okay. Then we can divide both sides of our equation by negative 80, and we get 0.1 equals cosine of C. Now to find our angle, we're going to use inverse cosine. So if we do inverse cosine of 0.1, we get 84.26. Now remember, trig equations have solutions in multiple quadrants. 0.1 is positive, cosines in positive in quadrants 1 and 4. if we mark that angle 84.26 or 84.3 if we went around, our quadrant 1 solution for C is 84.3 degrees. Our quadrant 4 solution for C is 360 minus that value, which is 275.7 degrees. Now, the quadrant 4 solution does not make any sense because it exceeds the total number of degrees in a triangle, right? Only quadrant 1 or quadrant 2 solutions make sense for angle measures in a triangle because those are less than 180. So when we have one measure for angle C, it is 84.3 degrees. Now you could use law of cosines again to find angle A and then also to find angle B, or at this point now you can use law of sines to find your other two angles. When you're given three sides, there's only one possible triangle. So when you use law of sines and you potentially end up with two values for an angle, keep in mind that 84.3 is your largest angle. So it's not possible. It's across from the largest side, right? So your next angle would have to be smaller than that angle, and that will help you eliminate one of your potential answers for your angle using law of sines. So let's just work through it. Let's use law of sines to find the next biggest angle, which is angle B. So we do sine of B over side B equals sine of C over side C. Cross multiply, 9 sine B equals 8 sine of 84.3. Divide both sides by 9. So 8 sine of 84.3 over 9. Sine B is equal to approximately 0.88. If we sketch, we're going to have potentially quadrant 1 and quadrant 2 solutions for inverse sine. Inverse sine of that angle is 62.2 degrees. So one angle measure for angle B would be 62.2 degrees, or angle B could be that subtracted from 180, which is 117.8 degrees. But as I was saying earlier, angle C is the largest angle because it's across from the largest side. And so the other angles have to be smaller than 84.3. So 117.8 doesn't work, 62.2 does. And then we can find angle A by using angles B and C. Whenever you use law of cosines, there is only one potential triangle because three sides indicate a unique triangle, or side angle side indicates a unique triangle. This is standard 4.4 rather, using law of cosines.